In this video, we learn three types of coordinate systems. The first one is rectangular coordinate system. In the previous video, we have already learned this type of system. In this system, we take three axes, that is x-axis, y-axis and z-axis, which are three mutually perpendicular lines. That is, these three angles are of 90 degree. This point we call as origin. To locate any point in three-dimensional space, we move distances along x, then y and z axis to reach a point. So x, y, z are the distances moved along x, y and z axis respectively from origin to reach this point. Then x, y, z will be coordinates in this system. Now we'll also learn cylindrical coordinate system, which is another orthogonal system of coordinates. That is the direction in which we'll move or we'll find the parameters or coordinates of a point are mutually perpendicular. Let us see how we find coordinates in this cylindrical coordinate system. Let this be a point on this cylinder P, which has coordinate x, y, z in rectangular Cartesian coordinates. We drop a perpendicular from this point P on the xy plane. Let the foot of perpendicular on this plane be named as M. So this point is M. We join this M with origin. Let us take this length of OM as R, this angle, that is MOX, as theta, and this length MP or PM, which is length of perpendicular from point P on xy plane, as Z. In the Cartesian system, this is defined as Z coordinate. This is also defined as Z coordinate in cylindrical coordinates. So in cylindrical coordinates, we have any point located in three-dimensional space by giving these three numbers, which are R, theta and Z. This diagram shows their definitions. Let us see, if we are given x, y, z, how we can find its cylindrical coordinates. So we are given x, y, z. We see that the z coordinate will be simply the value of z. Now we are required to find r and theta. R is length of OM. We see that to reach this point M, we'll have to move distance x along the x-axis and then distance y along y-axis, because this point M has coordinates x, y, 0, because this is the foot of perpendicular from P on the xy plane. Xy plane has equation z equal to 0, so its z coordinate is 0, while x and y coordinates are x and y respectively. So we see that this length is y and this length is x. So as this is a right angle triangle, we have r as square root of x square plus y square. So r is square root of x square plus y square. Now we'll find this theta. In this triangle, we have theta, that is this angle, as tan inverse of y upon x, because tan theta is equal to y upon x. So theta is tan inverse of y upon x. So we see that we can convert x, y, z in r, theta, z, that is cylindrical coordinates. Let us see how we can convert a point given in cylindrical coordinates into corresponding point in Cartesian system. We see that r cos theta will be this value of x. So x is r cos theta. Similarly, y will be, that is this value will be r sin theta. So y is r sin theta. Now z coordinate is simply z. So we see that we can convert r theta z into this xyz. we see that the direction of r is along this OM, that is this direction, that is the radius OM extended. The direction in which we measure theta is tangent at this point in the direction of increasing theta. So as we are measuring this angle theta along the with the positive x direction, that is it will increase in this direction. So direction of measuring theta will be this direction, that is tangent at this point M in the direction of increasing theta, because theta will increase like this. So this is the direction of theta, this is the direction of r, and this direction of positive z axis is the direction of z axis. So we see that r is perpendicular to this theta direction, because this is a radius and this is tangent at this point M. So we see that direction of measuring r is perpendicular to direction of measuring theta. Similarly, this z direction is perpendicular to this xy plane, hence will be perpendicular to both this theta and direction of r, because both this r direction and theta direction lie in this xy plane. So we see that the three direction along which we are measuring r, theta and z are mutually perpendicular, hence this is a orthogonal system of coordinates. Now we will learn spherical polar coordinates, or simply spherical coordinates. We have drawn a sphere of radius r. Let there be point P which in the Cartesian coordinates has coordinates as x, y, z. This is our origin. We join this O with P. So this length OP will be r, because this is a sphere of radius r. We take this angle between POZ as theta. So this angle is theta. We drop a perpendicular from P on this plane xy, and this foot of perpendicular is M. We also join this OM. Let us take this angle as phi. So in spherical polar coordinates or spherical coordinates, we take coordinate of a point as r, theta, phi. These three numbers will uniquely define a point in three-dimensional space. Let us see how we can convert a point given in Cartesian coordinates into a point in spherical coordinates. So we'll find r, theta and phi for this x, y, z. As this PM is perpendicular on xy plane, that is OM and MP will be perpendicular. It is clear that from definition of z coordinate we have PM as z, that is this length is z. We drop a perpendicular from this point P on the z axis. Let us name this as Q. So we see that OQ will be equal to PM. So that is, this is value z. That is r cos theta in this triangle OPQ will be z. So first we see that z is equal to r cos theta. Similarly, this PQ will be r sin theta. So PQ, which from this diagram is also equal to this OM, is r sin theta. Now we drop a perpendicular from M on the x-axis and also a perpendicular from M on y-axis. So from definition we have this value will be y and this value will be x, because this point M, which is foot of perpendicular from P on the xy plane, will have coordinate x, y, 0. That is, these value will be x and y from the definition of coordinates of a point in three dimension. So we see that this OM is r sin theta. Taking cos phi will give us x. So we have x is equal to r sin theta, that is OM, and OM cos phi is x. So r sin theta cos phi is x. Y will be equal to r sin theta, and y is OM sin phi, that is r sin theta sin phi, and z is r cos theta. So this gives the relation between xyz and r theta phi, and also a method of converting r theta phi to x, y, z, that is conversion from spherical coordinates to Cartesian coordinates. Now we'll see how we can find x, y, z in r theta phi. This r is equal to length of OP. So OP is equal to square root of OM square, that is square of this length, and this MP square, that is Z square. We see that OM square is x square plus y square from this right angle triangle. So r is equal to square root of OM square, that is x square plus y square plus z square. Now we'll find theta. In this triangle OPQ, we see that tan theta is equal to PQ upon OQ, that is PQ upon this OQ is Z. Now this PQ is equal to OM, and OM is equal to square root of x square plus y square. So we see that tan theta is square root of x square plus y square, which is length of OM, and also PQ upon Z. So theta is tan inverse of square root of x square plus y square upon Z. Now we'll find this phi. Phi is simply tan inverse y upon x, as tan phi is y upon x. So phi is tan inverse y upon x. So in this way we can find r theta phi given x, y, z, and we can also find r theta phi. We can also find x, y, z if we are given r theta and phi from these set of relations. These spherical coordinate systems and cylindrical coordinate systems are very important in the study of fluid mechanics and various other topics in various fields of engineering. Let us solve few questions. Convert rectangular Cartesian coordinates 2, 4, 6 to spherical coordinates. So we are given x, y, z, that is 2, 4, 6, and we are required to find coordinates of this point in spherical coordinate system. We see that r will be equal to square root of x square plus y square plus z square, that is 2 square plus 4 square plus 6 square, that is taking 4 common we have 2 outside the square root, and this will be 1 square plus 2 square plus 3 square, that is 2 square root of this will be 1 plus 4 plus 9. 1 plus 4 is 5, and this becomes 2 square root of 14 is the value of r. Now theta is defined as tan inverse of square root of x square plus y square upon z, that is tan inverse of square root of 2 square plus 4 square upon 6, that is tan inverse of this is 4 plus 16, that is 20, or 2 square root of 5 upon 6, that is tan inverse of square root of 5 upon 3. Now phi is equal to tan inverse of y upon x, that is tan inverse of y is 4 and x is 2, so this is tan inverse 2. So this is value of r, this is value of theta, and this is value of phi. Now we will convert this point 2 comma 4 comma 6 in cylindrical coordinate system. That is, we are required to find r, theta and z. R is equal to square root of x square plus y square, that is square root of 2 square plus 4 square, that is square root of 4 plus 16, that is 20, or 2 square root of 5. Theta is tan inverse of y upon x. Also note that this has same definition as phi in spherical coordinates, so this will be tan inverse 2. And z coordinate will be simply value of this z, that is 6, because this z is same as z in the Cartesian coordinate system. So 2 comma 4 comma 6 has coordinates in a spherical coordinate system as 2 square root of 14 comma tan inverse square root of 5 by 3 comma tan inverse 2, and in cylindrical coordinates it has r theta z as 2 square root of 5 tan inverse 2 and 6.